Consider the circuit represented in figure 10. L1, L2, and L3 are lamps. So here they did not mention whether the lamps are identical or different, and we are not going to use or we don't need to know whether they are identical or not in this exercise. Anyway, if L1 burns out, what happens to L2 and L3? So we have here that L1 is connected, as you can see, in parallel across the terminals of the battery. So we have the base of the lamp connected to the positive terminal of the battery, and the contact is connected to the negative terminal of the battery. So these are connected in parallel externally. Now we have L2 and L3 connected in series to the battery because only one terminal is connected to one terminal of the battery, and so on. Now if L1 burns out, what happens to L2 and L3? So if L1 burns out, L1 acts like an open switch. So we have to check if there's a closed pathway for the current to pass through L2 and L3 or not when L1 opens. So the circuit could be represented in part A as such. We have the positive terminal of the battery. This is a sketch. L2, L3, and externally L1 is acting like an open switch. So this is L2, this is L3, and L1 is here, but because it's burnt, it acts like an open switch. So when the current comes out of the positive terminal of the battery, it finds two pathways. However, this pathway is open, so it doesn't go through it. Then it continues its way and finds a closed pathway through L2 and L3. That's why L2 and L3 remain functioning as they were functioning. Okay? So if L1 burns out, what happens to L2 and L3? They remain functioning in the same manner. Now, if L3 burns out, what happens to L1 and L2? Now the circuit in B becomes as such. It becomes, this is the positive terminal of the battery. L1 is connected to the battery in parallel to it. This is L1 now. And we have L2 connected as such. And L3 burns out. It acts like an open switch. Then we have the wire here. So does the current have a closed pathway to go through L2? No, it doesn't find a closed pathway. That's why L2 doesn't glow. However, let's check the branch through which L1 is connected. So the current coming out of the positive terminal of the battery goes through L1 and finds a closed pathway. That's why L1 glows. So we say if L1 burns out, L2 and L3 remain functioning in the same manner. B, if L3 burns out, L2 turns off because it is in series to L3, and L3 acts like an open switch. Now, 8. The dry cell in the circuit of figure 11 has a voltage of 9 volts. So this is 9 volts here. The voltage of the normal functioning of L1 is 2.3 volts, that of L2 is 9, and L3 12. So these are the rated voltages of each of L1, L2, and L3. This means that having different rated voltages, this means that the lamps are not identical. Okay, so A, describe the brightness of each of the three lamps. Being connected in parallel, U battery equals U1 equals U2 equal U3 equal 9 volts. By law of uniqueness of voltage in parallel grouping. So now U1 has 9 volt, U2 has 9 volt, and U3 has 9 volt. In order to determine or describe the brightness, we have to compare their voltages to the rated voltage. So as for U1, which is equal to 9 volt, this is greater than its rated voltage, which is 2.3 volt as given. So L1 glows brightly and may burn out. U2 equal 9 volt is equal to its rated voltage, so it glows normally. And U3 is equal to 9 volt, which is less than its rated voltage, less than its need. So it glows weakly. Number 9. The 9 volt cell is formed of a number of dry cells of 1.5 volt each that are grouped in series. What is that number? We know that I said before in this book, when they mention series, they mean series aiding Okay, so we know that in series aiding, in order to find the total voltage of the batteries, we have to add them up. So instead of saying 1.5 plus 1.5 plus 1.5 and times, okay, and represent the number of the cells, we can directly divide 9 by 1.5 in order to know the number of the dry cells connected in series aiding with respect to each other. So 9 volt divided by 1.4, we have 9 volts divided by 1.5 volt per cell. This will be 6 dry cells. So the number is 6. If you want to draw now a diagram, we can draw it in two different ways. So the first way here is positive, negative, positive, negative, positive, negative. These are 3. Now we still have to draw other 3. Positive, negative, and positive, negative. Okay, I'm not gonna show the total or the whole circuit. I'm only showing the grouping of the dry cells. So these are 6 dry cells connected in series aiding. They act like they are equivalent to one 9 volt dry cell. So here each one is 1.5 volts. Altogether, when connected as such, they act like a 9 volt dry cell. Or some may start by representing the negative, changing the orientation. So we can say that negative, positive, negative, positive, negative, positive, 3 times, negative, positive, negative, positive, and negative, positive. So in the series aiding, the positive terminal must be connected to the negative terminal of the other dry cell. Okay, so again, this is equivalent to a 9 volt dry cell. Equivalent, we write it as such. So this is the symbol for equivalent. Now the circuit of figure 12 is formed of 3 dry cells and a lamp whose voltage of normal functioning is 6 volt. How are the cells grouped? As long as the negative is connected to the positive, the negative connected to the positive. Okay, so this is series aiding. What is the voltage of the grouping? We have to add them up. U grouping equals 3 volt plus 1.5 volt plus 4.5 equals 9. Does the lamp function normally? So in order to know whether the lamp functions normally, we can substitute all these batteries by an equivalent one, which is 9 volt, because we obtained the sum equal 9. So this is a 9 volt dry cell connected to a 6 volt lamp. What do you mean by 6 volt lamp? This means that the lamp needs 6 here represents, or this indication represents the rated voltage. So now only the lamp is connected to this 9 volt battery. So the whole voltage of the battery is given to the lamp. We say that U grouping equals U lamp equal 9 volt by law of uniqueness of voltage in parallel grouping. Now the lamp does not function here. The lamp does not function normally since 9 volt is greater than the rated voltage, which is 6. So it glows brightly and may burn out.